we have a demo. Tanner, our analytics engineer, of our very own, Tanner Beam, will now share a walkthrough of the tutorial that he wrote on using GX with Databricks. Tanner, I'll just let you take over. Would that be the best way?
Yeah, sounds good. Thank you, Josh. Oh, good. I have to allow. Sorry, I'm on a new computer and it's making me give permissions to Zoom. Oh boy.
Classic.
See if this works.
You
Did not
might
see
need
this
to
coming.
sign off and come right back again.
Okay.
Right.
Thank you. I'll be right back.
No worries. In the meantime, any questions you have about GX Cloud, what Susie just talked about, or questions about Great Expectations in general? Happen to bring up any, happen to entertain any comments, questions?
Okay, let's try this again.
There it is. I see it.
Okay, sorry about that. Okay, so today I'm going to talk about this workflow I put together with Databricks and Great Expectations. I think most people in the data space probably have some level of familiarity with Databricks. It's a bit of a one-stop shopping thing for everything, data engineering, data science, BI. It's just a full-featured kind of platform, just all sorts of stuff going on, and it's a very popular solution. We use it pretty extensively here at Great Expectations for our internal analytics, and I know we have a lot of external users who are also big Databricks fans. So I have this blog post that was published sometime last month, and it'll give you a step-by-step walkthrough of how to clone this repository and configure a cluster, configure your credentials, and basically it's kind of just clicking run on a notebook because everything is in the back end and utility modules, so you don't have to actually go through a lot of code. Ideally, you can just kind of get up and running pretty quickly, and then if you want to modify it for your needs, you can start diving in to what's in there. But the idea is just to really get started pretty quickly without having to get into the nitty-gritty of really how Great Expectations works. You can sort of onboard at your own speed and sort of look at, I guess this would be a bit of a real world example, because I actually do use this same framework in the data engineering workflow here at Great Expectations. So I'm just going to kind of walk you through the steps. I'm not going to read line by line, what's in the blog post. I'm just kind of going to do what you need to do as a little bit of a supplemental information thing to the blog post. So basically the requirements for this are you need to have Databricks. You need to have Databricks configured with your Git repos. So it doesn't have to be GitHub. It does other, Bitbucket or GitLab or whatever. I can't remember the names of the other ones. I think GitHub is still the most popular one, but you can configure it to work with other flavors of Git. But you basically need to generate a Git, personal access token and configure it in Databricks. So that is a requirement. The other thing you need is GCP ability to create a service account. So you might have to get your DevOps team to help you with this or something. I did not to really create the service account, but I needed a project. So here's the project page in Google Cloud. And the reason why we need this is because we're going to be pulling data from a BigQuery public data set. So there's all these data sets available from BigQuery data public data sets. It's really like a lot of data in there, and it's free up to a certain point. I think if you query a bunch of data, they're going to want you to have a credit card in there. But it's quite a lot of data that you can query for no charge. There's a lot of stuff in there, and one of the things that we're interested in that's in there is how many downloads of Great Expectations are we getting from PyPy? So that's really what this workflow is for, is just getting that data, getting it every day and writing it to our data lake. So in order to create service account credentials, you basically have to create a project. So this is where I had to get my DevOps team to help. Just like, hey, can you create me a project called BigQuery PyPy Stats? Once that happened, I was able to create a service account. Here's my service account, and give it the right permissions, and then actions. You can manage keys, and here is access keys. So I can actually make a new one and create a new key. I'm going to get a JSON, that's the recommended one, and create it. And that actually just, I don't know if you saw the pop-up notification from Firefox, but that actually just saved the JSON file to my default local download location. So it's probably in, my home directory in the downloads folder or something like that. All right, so that's kind of step one, because you have to have this service account key to be able to access the public data. And in the blog post, I outline, where the data comes from, and there's information in Google Cloud about how much you can query before you have to pay for it and all that kind of stuff. So now we're back into Databricks, and we need to clone this repository. So the repository is here. It's my personal account, and this is open. You can fork it, you can clone it, whatever you like. I'm just going to clone it. And I'm going to go up to code right here. I need the HTTPS link. So typically, if you're cloning locally, you're going to use SSH, but this is in Databricks, so I'm going to use the HTTP link. And these are kind of the default folders that are created once you put your personal access token for GitHub. So you can certainly do it in your personal folder if you want to. I'm going to put it in this folder called dev. And it just depends on how you have your repos directory structured, but I'm going to put it into dev. I'm going to go to add repo. I'm going to put the link to the URL there, and I'm going to call it GX Databricks demo. Create repo. Okay. Now we have the repo in there, GX Databricks demo. We're in the main branch. Can switch branches up here with this menu. And the next thing I need to do is get my service account credentials in here. So you can see it cloned all this stuff, including, the git ignore, the folder with the blog contents, a config file. So I need to get those service account credentials in there. What I can do is go up to this menu and do import. So I'm going to do a file import. I'm going to browse. I'm going to look in my downloads folder. Oh, okay, there we go. I'm going to just open that file with some inscrutable name there and then import it. Okay, so there's my service account credentials. They have been imported. It's a JSON file. Now I need to mess with this config file because people are going to have different file names, etc. So I'm going to go open this config.yaml, and I've got some comments in here that kind of explains, this is what the file structure looks like for Databricks repos. This is the repo directory, in this F string right here. This is the repo directory. Where are we at? We're in dev. We're in workspace. We're in workspace repos. sorry, repos. They changed the menu a little bit, but basically that's where you're at. You're in workspace, repos, and then this is the dev folder, and then this is the name of the repo. Okay, so we're already in dev, so that's good. The repo name, actually, what did we name the repo? I think we named it GX Databricks demo. So I'm going to change the name here. What do we name our service account credentials file? Let's see. Well, it's something, I don't know what that is. So I'm just going to rename it. I'm going to call it, service account creds.json. Okay, back to the config file. Come on. Okay, back to the config file, and we called it service account creds.json. This is where we might store our Great Expectations stuff in the directory structure, and then this is just the name that you can give to help identify some of your Great Expectations assets. But I'm just editing this file here, in Databricks, so I don't have to do the whole push-pull thing. If I edit it locally, then I got to push it to the repo and pull again. So this will just save it within the repo, which is nice. It's got a whole autosave thing. That's just getting edited in real time. Okay. Now, we basically have most of the code in this utils directory. So it's these Python files. These are not notebooks. These are just vanilla Python files. And all of the logic is pretty much contained in here. So you see like the Great Expectations utilities. Oh, this is where I have all my Great Expectations imports, my datetime stuff. This is where I've got some classes defined. And so all of the workhorse stuff is defined in here. But you don't really have to worry about that right now. If you want to worry about it later, you can. Right now, we just want to get some data, I think, and validate it with Great Expectations. So I might go to my source folder, and here's my workhorse notebook called PyPy package downloads. Okay, I need to connect to a cluster. So I already configured a cluster earlier, the GX Databricks demo cluster, and I gave it this runtime, and I gave it this worker type. You can do all this, with the JSON config as well, if you just have, or you can do all this stuff with Terraform. I just quickly created a cluster in the UI here, and I'm going to attach to that. But, when you create a cluster, most people in Databricks can just create a personal compute policy cluster, and that's totally fine for this. You don't need a lot of resources to do this, especially if you're just getting 1 day of data at a time or something like that. So back to my notebook here, and you can see this is where it's going to do what's called a notebook scoped install of dependencies. You can also install stuff directly on the cluster. You can actually install libraries to the cluster if you want to. In this case, that would be what's called a cluster scoped install. So, anytime you're attached to the cluster, those libraries are available. This is what we're doing. We're doing called a notebook scoped install, and Databricks documentation covers all this stuff. But we're just basically saying, hey, magic pip install these libraries, and then I want it to be at least this version, at least this version. All you need is Great Expectations and this pandas GBQ. GBQ is an abbreviation for Google BigQuery, but basically this library allows you to query to connect to BigQuery using those service account credentials, and you get it as a return the results as a pandas data frame. So it's a nice little library. So I'm going to connect to my cluster called GX Databricks demo, and I'm going to go ahead and run this. And really, we can just run the whole notebook, but you can run it, cell by cell if you want to walk through it. And essentially what's happening in this notebook is I'm doing some setup stuff. I've got a parameterized date range. So it's like, what dates of data do I want? In this case, I think the default is just like yesterday. So I'm just give me yesterday's data, from the BigQuery. database. I have to write a query that's in Google BigQuery syntax because I'm using the pandas GBQ library, and it's the data is from BigQuery, so I have to write the query in BigQuery syntax, and so I just wrap it in an F string to keep it in Python, and then I have the date range, parameterized there, and we can pass in parameters using the Databricks notebook parameters, which is really nice. Then I get that as a pandas data frame. And then I create a validator, which is a particular workflow for Great Expectations. It's sort of a recommended workflow for creating an expectation suite. Then I create a checkpoint with that particular validator, and then my evaluation parameters, which is essentially dynamic time range. And then I run the checkpoint and say, hey, is there anything wrong with the data? And I check the results. I have this little method for the results class, or for the checkpoint run result class, data class that I've defined, and I say I'll allow no failures. And so this is all my just kind of personal logic for dealing with it. I'm basically extending some of the Great Expectations classes to suit my personal needs as a analytics engineer. But if this fails, then it'll fail the whole notebook. And so I can trigger notifications to my Slack, or I can say, oh, you know what, like there's something fundamentally broken. I'm going to allow that one failure for now so it doesn't kill the workflow, and I'll fix it later. So I could change that to 1 or something, see what the failures are. But the idea is that I would basically fail the workflow before I write data to the data lake, and then go inspect what the problem is. You can also be more permissive and get an alert that says, hey, the data failed, something failed, this column had too many null values or whatever, but I actually still want to write the data, and I'll fix it, further downstream or something like that. In this case, I'm just saying, no, like, do not pass go, do not collect $200. If there's something wrong with the data, just fail it, and I'll go investigate. I don't want to write data that's potentially, problematic. But you can do whatever you want with this. So I'm going to go ahead and run this whole notebook. And I believe we're in good shape, hopefully, because we've changed since we modified those values in config.yaml. Hopefully everything will work. We'll see. So this shouldn't take too long. By default, I'm just getting 1 day of data. If you query a lot of data, it's going to take longer, and you might need to spin up a bigger compute cluster. And the other thing you need to be careful about is, and I mentioned this in the blog post, is you could accidentally query a lot of data from BigQuery. So the way that I'm restricting this query is I'm saying, here's the BigQuery public database that I'm getting it from. And this is basically like a lot of stuff. And so you need to say where your file project is Great Expectations. So I have this notebook parameter up here. So only show me downloads of Great Expectations. Don't show me any library that got downloaded from PyPy. And then, here's the timestamp ranges between these 2 parameters. So I've got, passing a date string in there. So, I only want 1 day of data, because if you didn't specify those where clauses, you're going to be querying a lot of data. Just be cautious of that. Okay, so like I said, this is already parameterized, so you can pass these. You can change these parameters when you actually run the workflow. You can give it a dynamic date range. And specify this, but you can put in whatever parameters you want to. But when you have it in a scheduling, use the Databricks schedule or Airflow or whatever, you can this is already parameterized. You can pass in a dynamic date range to that. Okay, so we got the data as a pandas data frame, because we're using this read GBQ library. And then what does the data frame look like? Oh, it's a pandas.core.frame.dataframe. That's just your vanilla pandas data frame. It's got 400,000 rows. they're non-null. They're mostly object type. So for typing, you might have to do some casting these as different types. This one ended up as a datetime, but the rest of them are just object type, um, which is fine for my purposes. But just be cognizant of that. And so you got okay, memory usage, 40 megabytes. So that's just one day of data. So like I said, if you queried a couple of years of data, it's going to be a lot, and it might blow up your cluster. Okay, so here's the validator. And all this, these are the rules that defines, what do I think might need to be checked with the data. So, before I create this validator, I'm going to go look at this data, so I'm going to do a bunch of exploratory data analysis and figure out what all this stuff is, and go look at the schema description in BigQuery, that sort of thing. So let me just show you what this looks like. Repos, utils, gx utils. So what this looks like is this method called default validations, which takes in a pandas data frame and a date range, which is a list of strings, and a great expectations validator object. And I basically create the rules in here. So, here's a list of my columns where I expect there to never be any null values ever. Oh, here's a list of columns where I expect there to be some null values. Okay, so now I'm using a list comprehension here and say validator.expect columns to not be null for every column in not null calls. So that's just creating these rules, and you basically go through that for all, and I put a comment for every different one, so you can kind of understand what's happening. Oh, column of timestamps and download time expected to be between. I expect it to be between this timestamp and this timestamp, and then I create what's called a evaluation parameter, because you don't want static values, because you're getting new data every day, and so you want to check the timestamps for that particular set of data. You don't want to pass in a static timestamp. Country codes. So I have what I did is I have a list of country codes in this file called ISO 3166.py. So it's just the dict with the country abbreviation and then the country name. And so I can create a rule that says I expect, here's the country code. So I just got the country codes from that file. And I say I expect the country codes in this data set to be in that list. So if I get a country code that's not in this list of country codes, that's a problem, right? I don't think we're creating a lot of new countries these days, but maybe I'm wrong. Anyways, this has all the rules, and then it just returns the validator. And so I'm getting a default validator with all those rules. Okay. So, you don't have to worry about too much what's in there unless you want to, but it basically creates the validator. If you want to write it to disk, you can, or you can just sort of create it in memory like this every time. It doesn't take that long, but if you're creating a really big expectation suite, you might want to persist this to disk and then change overwrite to false, and then go get it from the expectation suite from disk, so you don't have to run this every time. Then you create a checkpoint, you run the checkpoint, and you get results. So this is my extended class here called checkpoint run result. And then I check for failures, number of failures, 0, at or below failures allowed. Great. And then if I had failures, like I could list them there if I wanted to. That's pretty much it. This is not a fully productionalized example, because you would need to incorporate scheduling it, and also writing, persisting the data to disk. So essentially what I do is let's see where I have it. Repos, probably in prod. Repos prod. PyPy downloads. So example of what I do, and this really depends on your tooling and your preferences and stuff, but I get that data frame and I change the schema a little bit and I turn it into a Spark data frame. I take a Pandas data frame, turn it into a Spark data frame, and repackage it a little bit, put these into some structs. And, here's my Spark data frame, what it looks like. And, I'm going to have it partitioned on this column. And so I have some utility modules that are defined elsewhere. And I say, create a Hive table class because I'm using the Hive metastore. Here's my schema definition. Create that schema if it doesn't exist. And then, insert those rows into that Hive table, right? So it just gets new rows get inserted into every day. And then I expose that, in the SQL module or I don't know what's called, the SQL section of Databricks. It's like their BI tool stuff. And so, okay, I want to see, for starting year 2020, I can just parameterize this dashboard and, show me like what countries, people are downloading Great Expectations from. So largely United States, it's like Germany, Ireland, Australia, and, much less in other countries. And, okay, like show me a heat map of, Great Expectations version and Python version. So, most downloads are coming from Python 3.8 and Great Expectations 0.15. Show me, downloads by year and country. So you can just see, mostly these United States, Singapore, and Australia, and some European countries. But yeah, you can kind of do whatever you want with it, and hopefully it kind of helps you get started a little more quickly. I know this can be a lot of boilerplate setup for Great Expectations, but maybe this gives some indication of what you can do with it, how you can extend some of those classes. So if you're already familiar with Databricks, you're already familiar with Python, and you're already familiar with SQL, so you need to query that data out of the BigQuery database. Like maybe this is something you could play around with. So I think I'll just stop there. Maybe there's some Q&A or something like that.
Yeah. First of all, thank you, Tanner. That was great. Lots of really useful information, and for everyone, we will have this video posted on YouTube following this, so you can go back and watch this again. I can vouch for the fact that I went through this myself last week, and for someone who's never even logged into Databricks before, I got the whole thing working. So it's probably a good sign. All right, so feel free to just unmute yourself and ask questions. But we also already have one question in chat. So Emmanuel asks, how could this demo be inserted in the middle of a pipeline? And maybe a bit more context. Emmanuel, chime in here if if you have more information. But looking at our chat, you're thinking building a pipeline using GXDBT and also possibly Datafold and DataDiff. So is that kind of the pipeline you're thinking about? And you're asking how could we use GX with Databricks, or maybe use GX in that specific type of pipeline you're thinking?
Well, you can pretty much use Great Expectations and pretty much anywhere you want to. What I did was I actually got a data frame, in-memory data frame, and then I validated that with Great Expectations. But you can also validate stuff from file system. You can validate from blob storage, S3, or Azure, or GCP. So it's pretty flexible. You can pretty much do it wherever you want to. I chose to do it this way. So essentially, I'm validating, before I write it to the data lake, But I could also do it further downstream. Let's say all this gets written to the data lake, and then I have some more structured tables. Let's say I have a Snowflake data warehouse or something like that. I could also, check it, from the disk. So I could check the raw data in S3, or I could connect to the Databricks file system and check it before I write to Snowflake, or I could write to Snowflake and then connect to Snowflake and check it there. You can check it at multiple stages. There's a lot of extensibility with Great Expectations. You could just connect to a lot of different data sources in memory, file system. Pretty much up to you. Just depends on your needs.
Cool. Thanks. Any other questions?
Yeah, hi, my name is Ghana. I have a question about custom expectation. We are deploying a grid expectation Azure Databricks. We do not want to publish our custom expectation in grid expectation repo, nor deploy into Databricks folder where the grid expectation library goes. We are trying to test, the local mode option with the batch processing. We have difficulties, deploying these custom expectation resisting as local mode. Just want to get your opinion on this.
I don't have a lot of experience with custom expectations. I find there's quite a large number, and for my use cases, I've been able to find pretty much what I need from the standard expectations. So I can't really speak to what the limitations might be for this particular workflow.
Okay, local mode, right? I'm not sure, if anyone is using in production local mode custom expectation. Is it that quite common?
You're cutting out really badly. I'm sorry. I'm having a really hard time understanding. I made out a couple of words.
Hey, Ganapathy, maybe, I think I think you're breaking off a little bit. I think if you type your question in the chat, might be easier for us to, to get the question. Yeah, take it. We'll wait for you to bring your question, but that's probably easier. So while waiting for, okay, I guess he's trying to reconnect maybe. He just locked off. Anyone else have questions for Tanner? I'm going to give it.
Looks like there might be one more.
Yeah, there's one more from Emmanuel. My question was more about what could trigger today's demo notebook to run. Does database have concept of jobs, or do we need to use one of the cloud provider schedulers?
Databricks has a scheduler. You can trigger stuff, via the API externally, or you can do it within Databricks, and it has a nice little UI. I like it. I tend to use that. You can use something like Airflow if you want, but I find for most jobs that are not that complex, you can just run it with the Databricks scheduler, and I can show that really quickly if you want. So if you go to like workflows, here's a bunch of jobs, and let's say I have this one, and you can basically create like a DAG here. So most people are familiar with the concept of a DAG, but this is just the workflow dependencies. So this can be defined. So if I wanted to add a new task, I can tell it what the what's going to be run. In this case, it's a bunch of notebooks that are being run, but you can also do all of these other objects, and you can handle all your permission stuff in here. You can handle your dependency stuff in here. Sorry, your library dependencies in addition to your task dependencies. And I'm actually running this code directly from GitHub. So I'm not running it from the file system. So if my cat accidentally walks across the keyboard or whatever, it's gonna, and the file system gets modified, it's just gonna run it from GitHub. And, it's running at, UTC, 7 o'clock AM, UTC time every day. Here's the compute, here's the notifications, here's my Slack notifications. It's pretty good as far as I'm concerned. You might want to use, there are lots of other scheduling tools available, but if you want to just keep it all within Databricks, that's definitely an option.
Okay, Tanner. It's a Airflow, right?
Airflow is that's not a Databricks thing. That's another library, another Python library you could use.
Yeah, I'm aware of that flow, but I'm asking, is that what you show, the jobs, is it Airflow embedded inside Databricks?
No. It's Databricks. It's Databricks proprietary thing. It's the Databricks scheduling tool.
Okay.
We have another question from Amani, and then we'll go to one more from you, Emmanuel. So Amani has a question not related to Databricks, but can we validate CSV file data with Great Expectations operator without loading CSV file to database? We have a few engineers on here. I don't know if you can take this, Tanner. If not, maybe one of the engineers can, jump in.
Yeah, you got to get the CSV file into memory somehow. So whatever you can do with Python to get it in there, you can, curl it from a URL, or you can whatever you want to do. But you've got to get the CSV file in memory, or you need to have permissions to read from whatever file system you're choosing to use. So if I'm going to get it from S3, for example, I need to have permissions to connect to that S3 bucket, and then I'm probably going to use, some Python library. I might use Boto3 or something like that to read from S3. But pretty much anything you can do with Python to get the data available to you.
Yeah, it doesn't have to be a database, but you have to get at the data wherever it is. Great. Let me know if we answer that question for you, Amani. And then Emmanuel has another one. How can we log messages from out pipe process into cloud provider log system? Plain creation of file somewhere that cloud provider log system picks, or does Databricks? So basically you're asking how we can log messages to a cloud provider, and how could Databricks help with that?
You get all the Spark logs basically available to you. So that's just when you set up your Databricks workspace, use the defaults or custom setup, and you get all of your Spark logging that's getting written to somewhere. And that's also kind of available from the UI. Otherwise, just create a logger, use the logging utility in Python to do your own logging and pipe it to wherever you want to go.
Cool. And then last question, to use GX against big files, how big are they, Emmanuel? Is there support in GX for that, or do we need to split them up?
Yeah, I'm going to say your mileage may vary on that. We do support Spark, connecting to Spark data frames, both in memory and file system. And typically at that size, you're going to want to use Spark instead of something like Pandas, probably. But probably some expectations are going to be more efficient than others. I haven't done, a full optimization assessment of all the expectations to know which ones, sort of do parallel processing better than others. There's just a lot of variables, depending on your Spark configuration, how that might work. But I would definitely encourage, using Spark if you're going to be working with a large amount of data.
Okay, so it's more a Spark configuration thing.
Great expectations will come into the picture. I mean, first of all, yeah, if you're just talking about how Great Expectations works with Spark, yeah, probably the expectations themselves, like when you're running validation, that's probably where you might see some variation in performance. But just generally speaking, if you're working with large data and you're all as part of the workflow, you're doing, transformation. Spark is a good choice. So if you're already doing that sort of transform work in Spark, you can use Great Expectations with your Spark assets.
Thanks.
Cool. And then Amani has a question regarding Susie's info on, so Susie mentioned about being able to create expectations from a UI. When can we expect that feature? We don't have a specific timeline for you. I think we'll have more to show, hopefully, even by next meetup. But if you're really excited to see it, one way is definitely to reach out to Susie, and maybe have her show you some something so you can like give feedback, right? Like what Susie mentioned earlier. But Susie, anything to add there?
No, well said.
Okay.
Besides that, we're wrapping up the design right now. Yeah, probably the next few weeks.
Cool. Sounds good. Alrighty. Any more questions? We have a few minutes left.
Just to say thank you. It was a great demo.
Yeah, I agree. Thanks for just dropping so much Databricks knowledge on us, Tanner. That's great.
Yeah, my pleasure.
Okay, well, I think that was pretty good note to end on. Thank you everybody for attending. If you have more questions, please join our Slack. I will drop the link in the chat again for any follow-ups, and look out for the recording of this on our YouTube channel, and see you all around, and see you all next month. Bye everybody.
Bye-bye.
Bye.